ArcelorMittal and Purdue Calumet have had a strong partnership for decades. There's been exchange of students with the company. There have been engineers from the research center who have taught at Purdue Calumet. So we have considered this part of our family for a long time. The Center for Innovation and Visualization has been even a closer partnership from the very beginning. I think we were probably the first company to have projects, and now we have by far the most number of projects expanding to many of our plants. And we have been very happy to support this center and to support Purdue Calumet with these programs, which have helped us tremendously with our facilities and our facility improvements, as well as having the interaction with many of the students and being able to work with them and have them participate and learn the steel industry and industrial process developments. CIVIS is changing the way by which we develop and improve our processes. In the past, if we would trace it in the past, we would have a concept that we would build a facility in the research center. We would study that for several years, well as having to construct it. From the basis of those results, we would go to a pilot plant and build an expensive pilot plant in which would take multiple years, and we would study through the pilot plant until we were convinced of the process, and then start designing the process, which would be a 5-6 year process. Through visualization, we can shrink the time to do that to get to final commercialization, but also the accuracy. Even though we may still build some physical models in some cases we might eliminate the need for it, but through visualization, through advanced science applications in heat mass transfer and fluid flow, through our type of processes in the steel industry, we can eliminate many of the steps. We can look at what if studies and analysis to eliminate having to rebuild equipment and shrink by half or more the time it takes and the accuracy of our final designs for industrial processes. I think the future of the advanced state-of-the-art technologies is almost limitless. It depends on the science, so the science has to be accurate. So it's not just visualization, but the models themselves need to be accurate, and as that advances, as well as the visualization techniques advance in concert with each other, we'll see more and more applications, more convincing applications, and it's almost limitless to your imagination and ability to conceive of the applications. Virtually everything in the three-dimensional world could be applied, but I would emphasize that for us, the models and the accuracy of the fluid flow and heat transfer models is essential as well. And so the work that's being done here and other universities to combine with visualization is very critical. Well, I just would also want to add that this type of institutional cooperation between industrial companies like ArcelorMittal and universities with their students and professors who can have the time and can focus on particular areas is very, very valuable to us. We look at this as the future. We don't intend in research laboratories to be studying more fundamental phenomena or have the time to put in centers like this. So this Center for Industrial Applications, I think, is the future of cooperation between universities and industrial companies. Well, I'd say we've come back for two reasons. One is the success that we've had in saving money and coming up with new designs and saving money with the applications, or in avoiding ideas that didn't turn out to be as beneficial as we thought they would be. But also our realization that supporting centers like this is the future in the future institutional cooperation and the way that business will be done between our company and universities, and so we want to enhance that. And as one success breeds to another success, we have publicized the successes, and we've had more confidence in trying more advanced applications.
When we realized we had a problem, we thought for a while how to do it, how to attack the problem, and how to respond to it. My boss at the time, Kurt Sangster, a sharp fellow, I think he was the one who had the idea to, because he had knowledge of Purdue through some other things that he was doing with the university, and became aware of Civis and the modeling group, and so I think it was his idea to let's see if we can bring them in to solve this essentially flow problem. Following a pollution control installation, we found that we had a derate in the unit where we couldn't get enough airflow through the unit. The fans that were previously capable of producing full flow were no longer. So we did experience a flow-related problem. Again, our awareness of the potential of Civis to research and conduct trial and error solutions to flow problems caused us to come to you. So again, it was a match of our problem with flow and realizing that you had a potential solution for studying, understanding, and resolving the flow issue. Yeah. Okay, the solutions that the Research Center provided, after understanding that the flow problem, we got inside and saw that indeed we did have a recirculation zone, we did have something robbing us of the capacity of the unit. We came up with different turning vane applications. We installed some turning vanes in the computer model and saw that the flow did change. It was able to change the pattern and the recirculation zone of the problem. Better yet, we were able to get inside and visualize it and see the recirculation, see how the recirculation changed as we modified the turning vanes. And so we'd come up with a second set of possible vanes. And we got the output of those and saw how things improved in this way and that way, and how the changes caused the changes to the turning vanes caused a change to the flow. So we continue using a trial and error method to continue modifying the turning vane design. And we went through some 40 plus different turning vane configurations before we finally chose the best one. So it was a great example of trial and error, get insides using the simulation and the visualization to understand how the turning vane configuration changes improved or didn't improve so well, and worked our way toward the optimal solution. It was a great example of working together very well with people who were quite motivated and eager to solve our problem. Very impressive. Following the study and of the various turning vane options to resolve the problem, we did implement one of the solutions chosen, the optimal of them. We were under time constraints because of an upcoming outage where we shut down for 4 weeks and do a bunch of other work on the unit. And so the group worked very well with us towards working up towards that deadline. And just before the deadline came, we chose the best solution and we bought steel to build that design. And we implemented it. And following the outage, when we got back online, we turned the key on and found out that sure enough, the derate was gone. We were now getting full flow through the unit. So the implementation of the solution coming from the computerization study was completely successful. The implemented solution was a dramatic cost improvement for us. We were derated on one of the unit to about 90% of its output, taking away 10%, which is tremendously valuable to us. The value of the implemented solution was estimated to be $1.9 million per year, and that will continue on forever. A dramatic result. I feel that the collaborations of local industry with the Civis folks are a dramatic win-win, both for local industry who can get modeling results, interactive work with the people doing that modeling are tremendously valuable to industry. I'm also aware that this is helping the students become developing as they develop into young adults and into the workforce, that they are, instead of just seeing problems out of textbooks, they're now working with experienced people in industry, understanding budgets and schedules and difficult problems and trial and error solutions. And so I think they too are developing. I truly think that collaboration with Purdue in this way is a tremendous win-win for both the students and the industry. I'm proud to have been involved and a great supporter because of that.
We chose to go with Purdue-Calumet, and we had the meeting. Before we had the meeting, our research background into Professor Chen's accomplishments was very impressive. She'd worked with a lot of industries. She'd delivered a lot of product to those industries in terms of things that they needed. It showed a good practicality working with industry. It also showed that she was willing to work with industry. She had actually gone out and helped them. And as we did more work, we found out, or more research, we found out that she could deliver practical results to the companies as they requested them. And that's what we were looking for, because there's a lot of research done by other organizations, but they have no practical consequence of what they've done. And you look at information, you get data and outputs and stuff, but you can't relate that into actual something you can use in the field. And that's what we saw, was a lot of publications, a lot of industry interaction, and continued interaction with those same industries. So there was a great long history of that also proved that she was capable. And so when we came here, we looked at the people that I started working with, not just Professor Chen. She involves her students, involves her other people, very close-knit with you, and that relationship works out very well because you have one-on-one contact with people, and that makes a lot of improvement in the products you're going to get. We came to Purdue University Calumet because we did some research concerning trying to do simulations, CFD type simulations, and we looked at several organizations, and the one that stood out was Professor Chen's work in this field. And so we decided to pursue that with her, have a discussion, and then we got introduced to the Civis side of what she did, and that even enhanced more what we wanted to pursue. So that's why we came to Purdue-Calumet. Seemed like a good fit for us, and they were very practical oriented, which is, you don't see that too much when you deal with universities doing this type of modeling. The biggest benefit I see to this type of organization, this type of interaction, is you're training individuals. Granted, they're more technical, but you're training people that are more in line with what the real world is out there. You're not just training engineers or some technical form of training with these individuals where they come to the school and they leave the school and they got all kinds of academic, but they have no practical experience. This interaction with the industry, I think, gives them a benefit of knowing what they're going to face out in the real world. It also gives industry a chance to interact with and find individuals that are more oriented to what they want. So it works both ways. And I think industry needs to support this type of facility, because some bigger industries may be able to afford to develop this on their own, but they're not. And so this is a way to share resources. And so I think this is a good place to do this, and I think she's done an excellent job of bringing it together. Okay. Lazar Anode Tech is a startup company that's curing anodes for the aluminum smelting industry. And we're just building a facility, but we had some good data from pilot plant studies, but we hadn't actually tried to build the facility we're doing now, and we were concerned about some of the results that we might get. So we wanted to model some of the features of that design, which is patented, and make sure that we got it right when we built this facility. So we came here to Purdue-Calumet, hoping that they could model both thermally and flow-wise our furnace for us and give us some insight as to things we may have to change. And we did have a successful model results, which actually showed us we needed to change our design. So we stopped construction and we started a change in our design, and now we're restarting construction with that design change. And we're continuing modeling with Purdue right now. The only problems that we were concerned about was the temperature and flow patterns within the furnace. And this is why we came here, just to get that. Since we don't have an operating facility yet, we can't pursue anything further than just doing a basic modeling of the structures and the design. And then we pursue later, hopefully, once we get it up and operating, trying to enhance and optimize that design through modeling. CIVUS, when we got introduced to the modeling and then the simulation, and finally, following the simulation, we actually got to see some things in 3D. We realized we had flow patterns of temperature and flow of gas that was different from what everybody had visualized in the past, which also showed us why we weren't getting the correct response in the heating of our anodes. So by doing that simulation and actually seeing what's going on, that promoted a change in our design, which we have, like I said, integrated now, and we're hoping that given the model results we just recently looked at, we think we've solved our problems and improved the quality of the product we're going to make.
CIVUS was founded based on the, we see increasingly demanding for the advanced simulation and visualization. Before it was formally funded, we had a lot of collaborative projects with industry, community to do some simulation. But then when we added the virtual reality visualization, and people found the integration of both simulation and visualization together actually can greatly increase the value of both simulation and visualization. And it's like a wow effect. So we got a lot requests to do project with us. So we also believe this is the future. We have been closely work with community and industries. I found this kind of partnerships is really a win-win situation. And people come to us because our approach is application-driven, and we can get the solutions faster. And also because we have advanced facilities and the software. Now, on the other hand, the university needs to collaborate with people to find out the real-world technical know-how, and also to get real geometrical and operating conditions. Furthermore, we also need some measurement data to validate our simulation results. So the more close interaction between university and our collaborators, the faster and better results we can get. And again, in return, our students learn and have great experiential learning experience, and those students are our future workforce. Anybody who has geometry, flows, or any process, product, and so that can vary from the steel industry, refining industry, energy, science, biomedical, any field. Basically, this kind of technology is very effective to apply to all kinds of fields. Students, of course, they are the one doing most of the work, and they learn through the real-world problems, so which we call experiential learning. And so they get well prepared. And so our students are really very demanding by the industry, and also they can also easily get into graduate school. Now, industry people, of course, get what they wanted, and we can, get the problem solved. And also, some companies told us direct the saving of the cost. And for example, one of the project we worked with NIPSCO saved $1.9 million per year. Another project with USD in Canada, so we help them reduce the Coke rate. If you need to spend the money to buy that amount of Coke, that is about $28 million per year. And they can get it in a very quick way. We want to continue focus on the innovation, application, and education. And I see the service will grow more, and want to really do all the project based on the needs of the community and industry. Also serve to the faculty for their research and teaching interests. And most important, we provide great opportunities for our students. We have 3 major missions at the center. The first one is, the keyword is innovation. We want to foster innovations through simulation and visualization using multidisciplinary approach. The second keyword is application. We focus on applied research to solve real-world problems and to make impact to the economic development. And the third mission is education-related. So we want to educate individuals and organizations in the use of simulation and visualization technologies. My passion used to be computational fluid dynamics simulation applied to industry. And so I was trained in CFD, which is computational fluid dynamics, about 30 years ago. And so I've been through all the development stages of how people finally believe the CFD can be very useful. Now my new passion is the integration of simulation with virtual reality. So I do believe this kind of integration is the future, and it really, really can help people get a solution faster and better. I'm very grateful and very fortunate to have great support from all kinds of people. First of all, the leadership of the university, they provide great support, and the faculty and students. Our students are wonderful. I'm very proud of them. They're dedicated, hardworking, and so they are really serious about what they're doing, and they know what they're doing. They really learn and grow through the project. And also I want to thank all the funding agencies and the advisory board members and all the collaborators from industry. Personally, I learned a lot from people I work with, and I always enjoy it.